Hello everyone, welcome to my channel IndiaGATE. This is Nandani Sharma, and in this session of the graph theory, I talk about Euler graph, Euler path and Euler circuit, which is really important for the gate purpose. Now, come to the point. What is a Euler graph? So here, definition of the Euler graph is defined in two conditions. First condition is all the vertices are even degree, and second condition is that connected graph contains an Euler circuit, means starting and ending node are same in this circuit. Now come to the examples for more clarification of the point. So here first example is given like that, and graph is given here. Now the degree of A is 2 and degree of V is 2 and if degree of C is also 2, means here vertices are having same degree, means that is your even degree. So we say that it is your Euler graph. Why? Because here degree is even plus here circuit is also make, means here A, B, C, A, means here ending and starting node is same in this circuit. So this is your Euler graph. Now come to the next question to check whether the graph is Euler or not. So here graph is given like that, and now we consider first condition, that is it satisfied the all degree having the even degree. Yes, every vertices have the even degree, means A, B, C, D and E having the even degree. Now condition 2 is also satisfied. How? Where we start from the E, then A, then B, C, D, E. So we say that it contains an Euler circuit. So it is your Euler graph. Now come to the next question. That define that here in the given question, the four vertices have the one degree, like your A, C, D and E, and only B have the 4 degree, means here the degree is not even for each vertices. So we say that it is not a Euler graph, plus it is not considered the Euler circuit, so it is not your Euler graph. Now come to the next question. Here the degree is given like that, and every degree means the vertices A have degree 2, B have 4, C have 2, D have 2 and E have also 2. So we easily say that it is your Euler graph, and it is also contain the circuit, so it is your Euler graph exist. Now next question is defined as like this. Now this is Euler circuit or not. So firstly we count the degree of each vertices. If you found odd vertices degree, so you can easily say that it is not the Euler graph. So here each vertices have the odd degree, that is 3, so it is not a Euler graph. Now come to the next question. Here the next question is also contain the odd degree, so it is not a Euler graph. And last question is given here that here 3 all the vertices contains the odd degrees as well as even degree. But firstly we remain if any vertices contains the odd degree, so we directly say it is not a Euler graph. Now come to the what is the Euler path and Euler circuit. So there is very easy concept of the Euler path, that is containing each and every of G, means here in the path of the containing every edges of the G, but in the case of the circuit, Euler circuit, vertices of even degree, means all the vertices of the even degree, but exactly two vertices of the odd degree, which is Euler path but not is your Euler circuit. This is remembering point and very most important point for the Euler path and Euler circuit. Now come to the questions. So in the questions given the is Euler path and is Euler circuit. So here graph is given like that. Now we counting the total number of the vertices. So here exactly two vertices have odd degree. So we say that it is contain Euler path, but another way it is not contained the Euler circuit, as according to your most important points. So we say that here exactly of the vertices, two vertices of odd degree, that is your A and D. So it is Euler path but it is not your Euler circuit. Now come to the next question. Here graph is given like that and it contains exactly two odd degrees, like vertex E have 3 and vertex G have also 3 degree, that is your odd. So we say that yes, Euler path is exist but Euler circuit is not exist. Now come to the next question. Here in the next question define the all the graph vertices, but here we found that here is not exactly two vertices having the odd degrees, but here multiple vertices have odd degrees. So we say that it is not containing the Euler path as well as not containing the Euler circuit. Now come to the gate questions. So here in the gate question, G is a simple connected undirected graph. Some Euler vertices of G are of odd degree and add a node V to G and make it adjacent to each odd degrees vertices of G. The resultant graph is sure to be options A regular, option B complete, option C Hamiltonian, and option D Euler. Now come to the solution of this question. So here option D is correct. Why? For more explanation, we know that in any simple undirected graph, the number of the vertices having odd degree must be even. And now simple vertex V is connected to all of these even number of vertices which having the odd degrees. So degrees of V is also even. Moreover, now the degree of all the vertices which are connected to V is increased by 1. Hence, the vertices which has odd degree earlier now have even degree. So now all the vertices is graph have the even degree, and since the graph is connected, this graph is meet to necessary and sufficient conditions of the Euler graph. Hence, it is your Euler graph. Now this session is end here. I hope you understand all the points. Thank you for watching.